Hello, so this question is split linked list in parts. So you're given the head of the single linked list and integer k. So k represent you want to split the size of the linked list into k parts. So there are two constraints. So every single part should be as equal as possible to have a same size. However, if there is in the order of occurrence in the input list, and parts occurring earlier should always have the size greater than or equal to parts occurring later. So for example, this is size of 10, and then k equal to 3. We already know 10 divided by 3 is 3, 3 and 1/3, right? So there's 1 will be extra in one of the group, right? So you always want to put that additionals into the early linked list. So again, if this is 11, then you will have, uh, 11 right here. So you will have 5, 6, 7, 8, and then 9, 10, 11. So you don't have 8. So it's size of 4, size of 4, size of 3, and so on, something like this, right? So the idea is pretty straightforward. What you need to do is we want to count how many nodes in a linked list, and you later on you want to split, and that's pretty much it. And then we want to know how many remainder. So you can use mod to get a remainder. So total size mod by the k, then you know the remainder, and those remainder needs to put in the early list, right? And then if you divide by k, this is going to be min size. So total divided by k, every single linked list, every single sub linked list should have what the same size, right? So for example, the size of the so the size of this should be 3, 3, 3. So this is the min size, and then the mod k is what the additional linked list. So it should be 4 right here. Anyway, so that's pretty much it. And then once you put all the node in the sub linked list, you want to make sure this one dot next is equal to no. So initially it was 4 to 5, right? So you want to say 4 to no later on. So that's pretty much it. So all right, so size of the listener array is going to be, you're going to declare k size, right? And then return result. And then I need the size for total. And I also need to have a temporary node to traverse. So if node doesn't equal to no, size increment, no equal to no dot next. And then I need to have the min size is equal to what? The size divided by k. And then you can say remainder or leftover. I'm going to use leftover size mod by k. And then since I need to retraverse again the linked list, I need to reset my node equal to head. And I want to make sure every single last node, I want to make sure this dot next equal to no, right? So I want to have a temporary node. Let's go pre. Say equal to no by default. So once I traverse the current window, I want to make sure this will end up what? Point dot next. So so for in I equal to 0, I less than k, I plus plus. So this is going to be iteration for every single what? Every single sub linked list. And then the leftover, you want to add every single one of them into one linked list, as equal as possible, right? So that being said, you add one over here, you possibly add another one over here, and you might not add this one here, right? So it's based on iteration, right? So we already know we have the one for loop for what? Creating 3 linked lists. I haven't traversed the value inside the linked list, but that's pretty much it. And I'm using a node to traverse, right? So it has to be at another condition. Make sure no does not equal to no. Okay. So that's pretty much it for the for loop condition. All right. So I need to set the value, set the head value equal to no. So initially is 1. No is equal to head equal to 1. I set my first value equal to 1. Now I want to make sure the size of window. So the mean size is going to be this one, size divided by k, right? And then based on the leftover, if the leftover is greater than 0, then you want to add additional 1 into the into the current windows, right? So current window, you can say current window size is equal to mean size plus, if a leftover, this is greater than 1, then you want to add 1, else 0. Normally we say greater equal than 1, then you want to add 1 or 0, right? So you can say greater than 0. So if the leftover, whatever remainder you have, you want to keep adding to the early list, the sublist, right? So it should be this condition. All right. Now we just want to traverse the node. So using J. So I need to make sure I move my node to the next one. And also, before I move, I want to make sure I set the prev equal to the current node, and then move on to the next one. And then at the end, I will break out this for loop, and then probably right here I'll break out, right? So it's right over here. So the size is going to be 4, right? So 0 and 1, 2, 3, 4. So this is one J breakout, right? So J is right here, right? So the prev is right here. You break out the for loop, so that's why you want to have another step over here. And then this is pre, right? So pre, I want to make sure prev.next is equal to no. How do I determine prev is something? I can say if pre doesn't equal to no, by default is no. If I assign something, then I know that it's in the sublist, right? So I would say pre.next is equal to no. So that's it. I might miss the parentheses. All right, so that's pretty much it. So for the size, time and space. This is all of n for the time. This is all of n for the time. I mean everything, right? So this is all of k, and then depending on this windows, it's going to be all of c. But total, you will traverse every single one of the nodes, right? So this eventually will be all of n. This is all of n, and this is all of k. However, like you want to store the node into the list node array, right? So at the end is all of n, right? Because each k is depending on each windows, and that's pretty much it. So all of n for both time and space. All right, see you later. Bye.